Okay, let's dive into this. Welcome to our latest explainer. Look, if you're tackling the Cambridge AES and A-level computer science exams, specifically subject code 9618, we've just uncovered something truly fascinating. We are essentially looking at a direct leak from the examiner's playbook, and today we're combining ancient warrior wisdom with modern exam strategy. Think of this as the path of the samurai. We're going to teach you how to slice through exam questions with absolute precision, specifically mastering run-length encoding, or RLE compression. But we're not just reviewing the theory like a textbook. No way. We're doing it strictly through the lens of what the graders are actually hunting for when they read your answers.
Listen to this insight which comes straight from a senior examiner's perspective. The difference between a B and an A star in computer science often comes down to how well you understand run-length encoding. That really sets the stakes here, doesn't it? Mastering this specific topic isn't just another syllabus hurdle to clear, it's practically the key to securing that top-tier grade. To understand why, I want you to picture two students we see all the time. Let's call them Alex and Sam. Alex overloads every answer with raw computer science fact, but includes absolutely zero analysis. It's just a brain dump. Sam, on the other hand, rushes in, swinging wildly, and completely misses the command word requirements. They both end up with a B or worse because their answers are flawed and lack discipline. Today, we're finding out exactly what separates their answers from a flawless A-star performance.
To get that A-star, here's our battle plan. First, core principles. Second, the technical methodology. Third, critical examiner warnings. And finally, evaluating RLE algorithms. Let's get right into it.
Section 1. Core Principles. The Theoretical Architecture.
The foundation of mastering RLE isn't just memorizing a mathematical process. RLE compression is a theoretical architecture. It requires precise definitions and cross-topic connections before you even touch complex binary representations. Principal examiner reports consistently raise a massive red flag here. This is exactly where our student Alex goes wrong. Alex sees RLE and just starts writing everything about binary data. But candidates frequently confuse their terminology. If you explicitly define your terms and reference how RLE connects to broader data representation concepts, you immediately stand out to the grader. Imagine you're handed a string of raw binary in an exam, say a sequence of 8 zeros followed by 4 ones. You can't just immediately count them and write down numbers like Alex does. You have to explain the underlying logic of why compression is even necessary for that specific data type first. You need the discipline to set the state.
This builds directly into the Cambridge Assessment Framework, which targets 3 cognitive domains: knowledge and understanding, application, and analysis. The crucial thing to grasp is that the academic benchmarks prioritize analytical depth over superficial breadth. This is exactly why so many students, like our friend Sam, struggle when they see that string of zeros and ones. Sam just rushes past the analysis. Students try to skim the surface, offering a basic definition, instead of logically dissecting the data to show how the run-length pairs are actually formed and why that reduces file size. The examiners want to see your analytical gears turning. They want to see you apply a clear structure. Think of it like the Peel framework: point, evidence, explanation, link. Top students structure their answers this way to hit all 3 assessment objectives flawlessly.
Section 2. The technical methodology. The method mark strategy. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Welcome back. So this brings us to a massive game changer, the method mark strategy. Did you know examiners actually award marks simply for demonstrating the correct analytical process, even if your final mathematical answer is slightly off? It's true. Here is the exact 5-step procedural framework to secure those marks. This is your computer science success blueprint. Step 1, deconstruct the question. Decode the exact command word. Step 2, extract relevant data, like identifying the specific contiguous runs of zeros and ones in our binary example. Step 3, select your analytical framework, like that Peel structure we mentioned. Step 4, execute with clear notation. And Step 5, present your findings with correct terminology. If you explicitly write out that a sequence of 8 zeros is encoded by pairing the decimal count of 8 with the binary value for 0, and you show you're working clearly at every single step, you build an absolute safety net for your grade. You're transforming a messy, red-inked draft into a green check-marked masterpiece.
Section 3. Critical Examiner Warnings. Analyzing the pitfalls.
Now we're looking at the fatal mistakes derived directly from the principal examiner reports that actively cost students their top grades. First, answers are often way too vague. Examiners are actively hunting for specific technical details, not just general summaries.
Second, students constantly forget to check boundary conditions and edge cases. And third, answers are just not specific to the context provided in the prompt. Ignoring those boundary conditions is arguably the most dangerous pitfall. You always have to verify your results against the extremes. For instance, what happens to your compression ratio when a string doesn't have any repeating characters at all? You absolutely have to address these scenarios. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's do a quick interactive workshop here. The contrast between a passing answer and an A-star answer is incredibly stark. Look at the screen. A vague answer might just broadly state that RLE compresses data by making the file smaller. Find the flaw there. It's completely lacking technical depth. But a context-specific answer? It identifies the given information, applies relevant principles to the exact binary string provided, and uses clear technical language. It would explain that replacing adjacent repeating identical characters with a numerical count and a single instance of that character reduces the logical file size without losing any original data, making it a lossless format. That specific evidence-based reasoning is exactly what secures the top marks over generic, copy-pasted responses. It shows the examiner you aren't just reciting facts, you are slicing through the data with the precision of a master strategist.
Before we move on to the final evaluation stage, try out this quick memory hack. Take a moment after this explainer to create your own personal acronym for the factors affecting RLE compression. Having a mnemonic device is going to help you instantly recall those crucial cross-topic connections and technical details when you are under the intense pressure of the exam room. Think of it as your time management matrix. The best acronyms are the ones that are slightly ridiculous because your brain will actually hold on to them when the clock is ticking and you only have seconds left to write that perfect paragraph.
Section 4. Evaluating RLE algorithms. Algorithm quality.
The higher-order assessment objectives don't just want you to execute an algorithm. They demand that you evaluate and compare alternative approaches. This is the ultimate test of your strategy. When evaluating algorithm quality in RLE, you need to weigh these 4 criteria: time complexity, space complexity, edge cases, and performance. You have to break the problem down into logical steps, solve it systematically, check for reasonableness, and then use these exact criteria to make your case. Is the algorithm scanning the string efficiently? Is it actually saving space, or is the overhead too high? These are the justified recommendations that examiners are practically begging to see in your extended responses. Master this, and you have essentially unlocked the complete computer science answering system.
I want to leave you with a final, provocative question to test your new framework. If an RLE algorithm hits a massive string of completely unique characters, no repeating ones or zeros at all, how does this specific boundary condition affect its space complexity? Think about the procedural framework we walked through, and think about those edge cases. What happens when the compression attempt actually makes the file larger? Actively apply this exact strategic mindset into your past paper practice. Keep analyzing, keep evaluating, and build that discipline. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly sessions. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here.